What a blessing to have you here at Majestic Tutorials. Do you know that your academic success is guaranteed with us? Absolutely! You're set to perform excellently. Please help us grow and expand this young, vibrant channel by subscribing and sharing.
Welcome to the Majestic Tutorials. So in this video, I'll be handling you on the analysis of mixture of sodium chloride and calcium carbonate. So we'll be looking at the analysis of mixture of sodium chloride and calcium trioxocarbonate 4. So these are the two mixtures I'll be analyzing. Remember, they are going to be mixed together in the ratio of 1:1 by mass. So this implies that if we have 2 grams of this, you also measure 2 grams of this and mix it together. So first of all, you'll be provided with such a question that C is a mixture of 2 inorganic salts. What are the possible things we are going to be testing here? The possible thing we can test here is that we'll be testing for chloride ion, which is here. We'll also be testing for trioxocarbonate 4 ion, which is here. It's also possible we test for sodium ion, which is here. Testing for calcium ion might be difficult because when you use flame test, of course, sodium ion, the flame produced by sodium ion will mask that of calcium ion. But we will teach you these 4 ions just in case, okay? So first, likely we'll be asked to dissolve sample F. If I'm correct, we have A, B, C, then that D, E, F. Yeah, that's sample F. Mixture of sample F, which is this, to dissolve in water and stir, then followed by filter. Keep both the residue and the filtrate. When you filter, the thing that doesn't pass through the filter paper is called the residue. Then the part that passes through the filter paper is the filtrate. Now, in that case, you are going to have your test, observation, and inference. So, as usual, the first step, we have our serial number, of course, test, observation, and inference. So this is how it will likely go. So you now say F plus 10 ml. They will talk in cm cube. You use their same grammar, 10 cm cube distilled. We can use formula there, plus stir plus filter. Observation. You say there is what? White residue with colorless filtrate formed. So you say that F is a mixture of soluble and insoluble. If the question referred to F as salt, you say insoluble salt. If the question referred to F as compound, you say soluble and insoluble compound. But let's assume it referred to salt, mixture of soluble and insoluble salt. Now, the likely thing you might be told is to test the filtrate with litmus. So what do you now say here? The second one should be filtrate plus litmus. Remember, nobody will tell you to use red or blue. Just test with litmus. So you are expected to use both. So filtrate plus litmus. The filtrate will now be sodium chloride, while the residue will be calcium trioxocarbonate 4, which is insoluble, while this is soluble. Okay. And due to the fact that this is a salt of strong acid and strong base, that is sodium chloride, it doesn't hydrolyze in water. Therefore, it will give us a solution with pH of 7. So the observation here is say no action on litmus paper. No action or no color change. Observe, no action on litmus paper. Say filtrate is neutral. Filtrate is neutral. Okay. Then another thing possible is that you might be told, not might, this is compulsory, to the resulting filtrate, add HNO3 followed by silver nitrate followed by excess aqueous ammonia. Did you get that now? We are now testing for chloride ion. Let's get some things clear here. In the test for chloride ion, we either use these two sets of reagents. The first set is you will be needing silver nitrate, excess aqueous ammonia, and HNO3, which is constant. Then the second one, you might be needing dilute HNO3, then lead 2 triazonitrate 5. You don't need aqueous ammonia here. So it depends on the specimen, that's what they listed. I think the little I can remember, I did not see lead nitrate there, but it's supposed to be in the lab, all things being equal. Now, I'll teach you with that of silver. So we can test for chloride ion using silver nitrate and aqueous ammonia, and HNO3, dilute HNO3 is constant there. Or you can test for chloride ion using lead 2 nitrate and heating and allowed to cool. You don't need aqueous ammonia here. Reason is because lead is not a transition metal and will not form complex ion with aqueous ammonia. But silver, being a transition metal, will form complex ion with aqueous ammonia. So the idea here is that silver chloride is insoluble in water, whether hot or cold, but silver chloride dissolves in aqueous ammonia due to the formation of complex ion, which is one of the properties of transition elements. Then lead 2 chloride is insoluble in cold water but soluble in hot water. So if they use lead 2 nitrate, you'll be required to heat and allow to cool. Why are you heating? To make the water hot so that the lead 2 chloride formed will dissolve on heating. Then on cooling, it comes back again because it doesn't dissolve in cold water. So, but we are likely expecting that of silver triazonitrate 5 with excess aqueous ammonia. In whichever one I'm going to be using, what is constant is that there must be addition of dilute HNO3, either before adding silver nitrate or after adding silver nitrate. The reason for the addition of the dilute HNO3 is to prevent the precipitation of other insoluble salts of silver. This implies that we have other insoluble salts of silver. Remember, this test is all about double decomposition. Yes, because the silver nitrate is soluble, the sodium chloride itself, which is the filtrate, is also soluble. But when you mix the two, the silver ion now reacts with the chloride ion from sodium chloride. Silver ion from silver nitrate will react to form insoluble compound known as silver chloride. And this process is called double decomposition. That's exchange of radicals. Okay. Now, you have to make sure that the precipitate forming is silver chloride because we have other insoluble salts of silver, such as silver trioxocarbonate 4. Yes, is also insoluble, which means if you add silver nitrate to a trioxocarbonate, you will also notice a precipitate. But if you add dilute HNO3, this if the precipitate is that of silver carbonate, you will notice effervescence and that carbonate will dissolve. But if the precipitate is not soluble in dilute acid, it shows that it is not silver carbonate. Now, we are only focused that the precipitate formed must be silver chloride, and that makes our analysis directional, more specific, and more accurate, as we are no more wallowing in the midst of two options. Rather, the HNO3 will give you the authority to say this is chloride ion because silver chloride do not dissolve in acid, or silver carbonate, dissolves in acid just like every other carbonate. Okay, so we proceed. The next possibility we are expecting is to test for let me take this call. Okay, sorry for the break in transmission a bit. A call came in. Now we are going to do the test for chloride ion. I've explained the chemistry, so let's dive into it. I'm cleaning off the test because I want to maintain the table, manage the board. Okay, I don't know which one is. Okay, I think both are writing. So you'll be required to say maybe if there is any need of dividing into portion, but I don't think they will divide into portion. But if they do, just know if they tell you to divide, you now say first portion, aqueous. But whatever, you can now just say filtrate. Remember now, that filtrate should be aqueous, or you say the F aqueous plus what? AgNO3. Don't forget to put aqueous plus HNO3 aqueous, then plus excess dilute aqueous ammonia. Right? What should be observation? If they tell you to add silver nitrate first, you now say white powdery precipitate formed. Precipitate formed. No visible reaction on adding HNO3. No visible reaction with what? HNO3. That shows it's not a carbonate. You now say precipitate dissolved in excess what? Precipitate ammonia to form what? A clear solution. So immediately you add silver nitrate and it gives you white precipitate. You say chloride ion present. Then at the end, if it dissolves in excess ammonia, you say chloride ion confirmed. So that's it for test for chloride ion. The another alternative is that we might use lead nitrate instead of silver nitrate. So in this case, if they decide to replace silver nitrate with lead nitrate, see how the question will be constructed. It will now be filtrate of course, aqueous solution of it, plus PbNO3 bracket 2 or aqueous, both must contain HNO3, dilute plus dilute, please indicate dilute HNO3 plus heat plus cool. That's it. So your observation here, from here becomes the same thing. From white powdery precipitates formed, or remember you can say chalky instead of powdery, white chalky. Anyway, please subscribe to this young new channel. Please help me grow this channel. I thank my followers. Remember, this is an extension of Samaje's World Science channel. This channel is created to focus solely on tutorials. We'll be handling you squarely on tutorials, more educative, but the other channel will be focused on experiments, demonstrations, the real science, because the name is Her Majesty Easy World, but here is Majestic Tutorials. Please subscribe and share this video, and remember to rely on us for your academic success. we will serve you the way you want. If you want us to expand to a particular field, you can drop it there in the comment section. And I wish you the best of luck in your exams. Of course, having visited this channel is a guarantee they are going to do well. But don't forget to come back and testify. And the best thing you can do for us, the best thing is to subscribe and share. Give this video a thumbs up. Thank you for visiting. I'm glad having someone like you. So let's continue. So we say white chalky precipitate. White chalky precipitate formed, no visible reaction with what? With a dilute HNO3, dilute, please, aqueous. Now say precipitate dissolves on heating and do what? Reappears like African magic. Reappears on cooling. Like I've explained the chemistry, the same thing immediately gives white precipitate with lead. You say chloride ion present. But when it dissolves on heating and reappear on cooling, you say chloride ion confirmed. This implies that it is not only chlorine that can form white precipitate, chalky precipitate with silver or lead nitrate, but it is only chloride ion that would form white precipitate and will dissolve on heating and reappear on cooling with lead nitrate. Okay, and it is only chloride ion that will form white powdery precipitate that will dissolve in excess aqueous ammonia with silver nitrate. But it is not only chloride ion that will form white precipitate with silver nitrate. But what's the difference? That's the only one that will form white precipitate and it will dissolve in aqueous what? Ammonia. All right. So the next ion we didn't touch now, we did not touch about calcium and trioxocarbonate for ion. Okay, the next possible question to analyze this, you might be told to add, after the filtration, they say to the residue, add dilute HCl, add dilute HNO3, add dilute H2SO4. Any dilute acid will do it correctly, but it's not appropriate to use H2SO4 here because it will react with the calcium to form insoluble sulfate, which is calcium sulfate. But I don't know if they are scientific, they are only focused on set the exam for you, you write it and go your way. So I'll teach you in case. So the next possible question, which is sure, to the residue, add dilute HNO3. Just add dilute HNO3. Nobody tells you in drops, in excess here. No. If that question occurs, what happens? They are testing for triazocarbonate 4 ion. And the triazocarbonate 4 ion reacts with dilute acid to liberate colorless, odorless gas, which will turn lime water milky. And guess what? This gas is what? Carbon 4 oxide. Okay. Now, let's put it down in writing. We might see residue plus what? Residue plus dilute HCl. Remember to always put aqueous because we have a gaseous form. All right. Your observation is simple. Effervescence occurred. Remember, effervescence is the evolution of gas from liquid. Effervescence occurred. Colorless, odorless gas evolved. Say gas turned lime water milky. Gas turned lime water milky. You simply say CO2 gas from CO32 minus. Okay. So this is the way you handle this one. Then another possible thing, I hope I'm not blocking, maybe you see well. check it there. So another possible question is that they might tell you to use a spatula and hold part of the residue to a non-luminous flame of the Bunsen burner, or hold it in a Bunsen burner, a burning Bunsen burner. If they say residue after filtration, they are not testing for calcium ion, and you will report brick red precipitate. It will give it immediately. It dries off, it will likely give that thing, that brick red. But when they tell you to put the whole sample of F without dissolving it in water, if you are told to put the whole sample of F to a non-luminous flame without dissolving in water, you have mixture of sodium and calcium. Which one would dominate? Sodium, likely, because it gives stronger, powerful golden yellow flame. Okay, you just report golden yellow flame. In the inference, you say sodium ion, confirmed, because it is the only ion that gives a golden yellow to flame. But after filtration like this, you now see hold the residue to a non-luminous flame, you are reporting brick red or orange red in your observation color, or orange red flame observed. In your inference, you write calcium ion, confirmed, because calcium gives orange or brick red precipitate in test for during flame tests. Okay, so covering up possibility, we can see residue plus non-luminous flame. What will you observe is a brick red flame or orange red flame observed. You say what? Under here, immediately you write calcium ion, confirmed, since it's brick red. Although the best thing is to write calcium ion present. I wouldn't know, because I think let's use present here, because we need to view it through a blue glass. When it appears green through a blue glass, we can now say confirmed. But I don't know if they will take it into consideration. Okay, this is slash. You can either say this orange red or brick red flame observed. If you want to see all these experiments in real life where I'm performing them, you visit the Her Majesty's World Science Channel. I have shown the colors, even strontium, which is nice. Strontium is red, copper is green, entertaining. Barium is pale green. So just go to that channel and enjoy real science. And don't forget to subscribe, of course. I think these are the possible things they may ask us in this analysis of mixture of sodium chloride and calcium carbonate. Remember what I told you, that when you are told to hold even the filtrate alone, if you are to hold it in a flame, it will still give you, if they say filtrate, remember it's now sodium, that will be golden yellow flame. All right. Thank you for watching. God bless you.